The selected design, Good Boy, begins by firing two pistons. The start piston hits the start block attached to the top slider to push it toward the matrix, while the Morpheus piston pushes the Morpheus capture into position, simultaneously initiating the programming module system. Two arms fall on the far side of the modules, and a second firing of the start piston pulls the string attached to the pull joint, bending the arm to bring the modules into the home zone. A slot in the module wall also allows it to reach over other teams' mechanism and prevent module movement. Meanwhile, as the top slider extends towards the matrix, the sentinel hook grabs and pushes the sentinel into the EMP blast zone. As for the pill subsystem, pills are placed into two loading zones on a ramp in the pillbox separated by the pill walls. The device uses a switch to detect the pill zones. When the red zone is detected, the solenoid connected to the pill trigger is engaged and the pill walls are lifted. Two pills fall into the first red zone and the other two pills move to the next loading zone to be deposited when the next red zone is detected. The system was put into position at the start by the Morpheus piston and is held in place by the tension rope. An infrared sensor placed underneath it detects the top of the shield, aiding the device in completing the tasks within the time limit. Once the shield drops, the Morpheus net will rotate 360 degrees and grab Morpheus using power from the sprint hinge. A motor pulls the Morpheus capture back slider using tension rope. The device egresses using another motor and the egress pulley. The motor pulls on a rope attached to the top slider and pull it back to the base using the extra torque provided by the pulley. The device will shut off automatically after 40 seconds. Along with the selected design, four alternative concepts were developed in this design process. The first alternative concept, suspended lift, consists of a smaller ramp within a larger base. Segments extend outward, moving a forklift that takes advantage of Morpheus' protruding arms. A cart utilizes rolls down the ramp, pushing the sentinel into the EMP blast zone. A pill tube beneath the segments dispenses the red pills collectively. To sweep the programming modules into the home zone, two arms extend outward from the left and right of the mechanism. The arm motion is created using pneumatic pistons. Big Dipper, shown boxed, consists of a base composed of drawer slides. The Morpheus cup and pillbox sit on top of the last drawer segment. Once Morpheus' shield is released, the cup covers Morpheus and traps him. The pillbox dispenses the red pills one at a time into their correct pill zones using an IR sensor. Two arms extend from the top left and right of the base and move away from the matrix, pushing modules into the home zone. Lastly, a hook is secured to the sentinel and the sentinel pulley pulls it out of the home zone and into Zion. The third alternative, Scooper, consists of a rectangular base containing a smaller ramp within. The base has wide extending drawers which contain a pill tube and a Morpheus scoop at the end. The pill tube deposits the pills placed inside it using a trigger activated by a solenoid. The Morpheus scoop, located to the right of the pill tube, lowers upon the drop of Morpheus's shield using an IR sensor, and hits Morpheus backwards into the home zone. A ramp and cart are used to push the sentinel into the EMP blast zone. Lastly, two arms extend outward from the left and right of the mechanism. The ends of the arms are slightly angled and move away from the matrix to push modules into the home zone. The last alternative design, Escalade, is composed of a matrix arm that was launched out of the initial start zone by a piston. The arm extends and the Morpheus scoop and pill tube are contained at its end. The scoop hits Morpheus into the home zone and the pill tube places red pills into the correct zone. These tasks are accomplished using IR and color sensors respectively. Two arms at the top left and right corners of the base unfold and pull the modules into the home zone using a motor. The Sentinel hammer also drops from the matrix arm and strikes the Sentinel into an opponent's home zone. Using the criteria defined by the specification sheet and House of Quality, a third-level evaluation matrix is developed to rank how well the designs satisfy the customer requirements on a 1 to 4 scale. Good Boy best addresses these requirements with a total of 532 and a relative total of 0.22, with Scooper being the closest with values of 487 and 0.20. The difference is attributed to Good Boy's performance in collecting programming modules and its ability to egress. The former is from the design of the arms, which are positioned strategically to be pushed by the top slider and Morpheus piston for greater speed. The end of the arm is also designed to block competing teams from collecting modules if they reach the modules first, a valuable strategy that can save many points. The Morpheus capture in Good Boy is also the best out of the concepts, as the utilization of a net allows for a more secure grasp of Morpheus. In addition, the chosen design allows for a better egress compared to the others because of the torque from the egress pulley and the entire device being one connected piece. The suspended lift and scooper utilize carts on ramps which are unable to egress out of the EMP blast zone. It is important to note that Escalade had the best method to repel the Sentinel by hitting it into the opponent's zone. causing a deduction of their points. This subsystem, however, also runs the risk of modules into an opponent's zone. Regarding pills, Good Boy has a distinct advantage. Separated into two zones, the pillbox enables the mechanism to deposit two pills correctly at once, causing a significant reduction in time.
Good Boy was chosen as the highest scoring design due to distinct design advantages. This decision is supported through his performance in the mock competition.